Night, late wet season. A blackwater tributary of the upper Amazon basin, where the flooded forest stands half-drowned and silent under a ceiling of low cloud. The air is heavy with the scent of rotten blossoms, a humid stillness broken only by the intermittent drip of condensation from strangler figs and a distant metallic call of night insects. Beneath the surface, the water is a color of steeped tea, opaque and warm, absorbing light until shapes dissolve into suggestion. A broad, muscular form moves there with almost no disturbance, displacing leaves that drift like small boats on the skin of the river. The giant anaconda patrols the margin between open channel and submerged undergrowth, tongue-tasting chemical traces that linger in the water. On a narrow strip of higher ground ahead, where the flood has not quite claimed the forest floor, a Brazilian porcupine descends awkwardly from a cecropia tree to forage among fallen fruit. Its quills lie flattened for now, a dark halo against the pale mud. Neither animal has evolved for this encounter, yet the flooded season compresses territories, forcing the terrestrial and the aquatic into same shrinking spaces. The green anaconda, among the heaviest snakes on Earth, belongs to a lineage of constrictors that returned to a semi-aquatic existence millions of years ago as South America's river systems reshaped the continent's interior. Females can exceed 5 meters in length and weigh well over 100 kilograms. Their immense girth supported by water that neutralizes gravity's cost. Unlike most terrestrial snakes, their eyes and nostrils sit high on the skull, an adaptation convergent with crocodilians that allows the body to remain submerged while the sensory organs survey the surface. Thermal perception is limited compared to pit vipers, yet chemical detection through the forked tongue in Jacobson's organ remains acute, capable of tracing faint molecular trails left by mammals that wade or drink. Studies in the Venezuelan llanos and Brazilian wetlands show that large individuals feed infrequently but opportunistically, preying on capybaras, caimans, deer, and occasionally domestic livestock where human boundaries overlap floodplain habitat. Their metabolism is calibrated for long fasting intervals. A single large meal can sustain basic physiological function for weeks. In the flooded forests of the Amazon basin, seasonal hydrology dictates movement. During high water, prey disperses into the canopy and onto elevated ground, forcing anacondas to patrol submerged corridors where land mammals descend to drink or cross. This seasonal compression increases encounters with species not typically considered prey, including arboreal rodents that must ascend to forage when fruiting patterns shift. The Brazilian porcupine, a strictly arboreal rodent of the genus Coendu, occupies a different evolutionary strategy shaped by life above the forest floor. Its prehensile tail functions as a fifth limb, enabling deliberate movement through branches where leaves and fruit are abundant year-round. Quills, modified hairs with barbed tips, form a passive defense rather than an active weapon. Contrary to persistent myth, they cannot be projected. Instead, they detach easily upon contact, embedding in the tissue of a predator. Field observations from canopy studies in Peru and French Guiana indicate that most predation attempts occur when individuals descend to ground to access mineral-rich soil, fallen fruit, or to cross gaps in fragmented forest. On land, their movement is slow and conspicuous, an evolutionary trade-off for the energy efficiency of arboreal life. Their diet of leaves, seeds, and cambium shapes forest regeneration patterns, making them minor but consistent agents of seed dispersal. Ecologically, they occupy a middle trophic level, herbivore, prey, and occasional ecosystem engineer through pruning of vegetation. When floodwaters rise, however, the vertical refuge of trees becomes a trap of diminishing resources. Hunger and mineral deficiency can force descent even in high-risk conditions, placing them within reach of aquatic predators that normally hunt hoof mammals. In these moments, evolutionary paths that rarely intersect are drawn together by the physics of water and the biological necessity of feeding. The flooded forest is not merely a setting, but a seasonal engine that reorganizes life across thousands of square kilometers. In the Amazon's Várzea and Agapo systems, water levels can rise more than 10 meters between dry and wet seasons, transforming terrestrial pathways into submerged labyrinths navigable only by swimmers. For the green anaconda, this expansion creates a three-dimensional hunting ground where buoyancy allows a body of extreme mass to move with minimal energy expenditure. Radio tracking studies have shown that large females often establish loose home ranges centered on reliable prey corridors, game trails, narrow channels, and natural bottlenecks where animals are forced to pass. Vision underwater is limited, so the snake relies on vibration and pressure changes transmitted through its jawbones, detecting the subtle displacement created by a waiting animal long before contact is possible. Ambush remains a dominant strategy, a rapid forward lunge powered by axial muscles, followed by coils that tighten with each exhalation to prey. Contrary to older assumptions of suffocation, modern research using pressure sensors indicates that constriction primarily causes circulatory arrest, collapsing blood flow within seconds. Such efficiency allows the snake to subdue animals with formidable defenses, including hooves, antlers, and teeth. Yet every predation attempt carries risk. Broken ribs, internal injuries, or exhaustion can be fatal in an environment where recovery is slow and competition for carcasses is intense. For the Brazilian porcupine, survival depends less on speed than on deterrence. Each quill is a lightweight structure of keratin with microscopic backward-facing barbs that cause it to migrate deeper into tissue once embedded. Predators that survive the encounter may suffer infections or impaired movement for weeks. This defense is most effective against mammals that attack with the mouth or paws, such as ocelots or tyras, both documented predators of arboreal porcupines. Against a constrictor, however, the outcome is less predictable. The snake's attack is delivered with the head and neck, areas protected by thick scales but not immune to penetration. Veterinary examinations of wild snakes have occasionally revealed embedded quills, suggesting that encounters do occur, though rarely observed directly. The porcupine's nocturnal habits further complicate documentation. Most activity unfolds in darkness high above ground, beyond the reach of standard field observation. During floods, when branches or isolated islands and food sources dwindle, individuals may travel along exposed trunks or descend to floating debris, moving with unusual urgency. These forced movements create acoustic signatures, splashes, scraping bark, falling fruit, that can betray their presence to predators below. Ecologically, the encounter between anaconda and porcupine represents a convergence of mismatched adaptations, one built for silent aquatic ambush, the other for passive terrestrial defense. Neither has evolved specifically for the other, yet both are shaped by the same pressures of hunger, seasonality, and the indifferent mechanics of a forest that alternates between land and water. In the calculus of survival biology, the anaconda represents an extreme investment in ambush predation, a strategy that depends on patience more than pursuit. Unlike cursorial predators that expend energy in long chases, this snake's success lies in minimizing movement until a precise moment when distance collapses to nothing. Muscle fibers along its body are arranged for explosive contraction rather than sustained speed, enabling a strike that unfolds faster than the nervous system of most prey can process. Observations in the wetlands of Llano show that large individuals may remain motionless for hours, even days, positioned along game trails partially submerged in water that masks their outline. This stillness is not passivity but calculation shaped by evolutionary time. A missed strike wastes precious energy and may alert other animals to danger, reducing future opportunities. When confronted with unfamiliar prey, an animal whose defensive anatomy presents unknown risks, the snake does not reason, but instinctive thresholds still govern the decision to attack. Size, movement pattern, and proximity trigger the response. In flood season, when typical prey disperses and hunger deepens, those thresholds shift subtly. The anaconda becomes less selective, more willing to engage animals outside its usual diet, not from aggression but from metabolic necessity. For the porcupine, defense is not an action but a condition of being. Its body is a field of deterrence, a warning encoded in texture rather than behavior. Ethological studies of New World porcupines indicate that confrontation follows a predictable sequence: freezing, turning the back toward the threat, erecting quills, and producing low vocalizations accompanied by tail rattling. The goal is not a fight, but to persuade the predator that injury outweighs reward. This strategy assumes that most attackers rely on direct biting, a gamble that often succeeds because many predators learn quickly from painful experience. Yet against a constrictor that kills by pressure rather than teeth, the equation shifts. The quills may penetrate, but the snake's coils can still close if the initial strike secures the head or torso. In such encounters, both animals operate on inherited programs shaped by threats they commonly face, not by rare adversaries. The porcupine's slow gait, efficient in the canopy where falls are rare, becomes a liability on unstable, waterlogged ground. Its senses are tuned to detect aerial predators and climbing carnivores, not silent forms approaching through opaque water. The flooded forest erases the spatial separation that normally keeps these species apart, compressing their worlds into a narrow band of survivable terrain, where defense and predation meet without precedent. Another angle emerges through the lens of sensory ecology, the study of how organisms acquire and interpret information from their environment. The anaconda's perception of the world is dominated by chemical gradients and mechanical disturbance rather than sight. In tannin dark water, vision offers little advantage. Instead, the snake reads turbulence the way a terrestrial predator reads footprints. Experiments with captive constrictors demonstrate that even minute ripples can orient the strike direction, the lower jaw functioning as a vibration receptor coupled to the inner ear. Heat detection, while present in boas to a limited degree, is far less refined than in pit vipers, making warm-blooded prey only slightly more conspicuous than the surrounding water. By contrast, the porcupine's sensory priorities evolve for a vertical habitat, where depth perception, tactile feedback from whiskers, and olfactory cues guide movement along branches at night. When forced on the ground during floods, these calibrations become mismatched. Reflections on water distort visual cues, and submerged obstacles create unpredictable footing. The animal moves cautiously, pausing often, each hesitation extending the window in which a predator can close distance undetected. Neither animal is maladapted in absolute terms. Rather, each is optimized for a different dimension of the forest, and the flood season collapses those dimensions into a shared plane. A further perspective lies in the neutrality of nature's outcomes. Encounters between predator and prey are not contests of virtue or cruelty, but transactions of energy shaped by evolutionary pressures. The anaconda's feeding success determines not only its survival, but its reproductive potential. Females that accumulate sufficient reserves can produce litters of dozens of live young, each already equipped for independent life. The porcupine's survival, in turn, preserves a lineage of herbivores that influence forest composition through selective feeding and seed dispersal. Long-term ecological monitoring in parts of the Amazon basin shows that fluctuations in predator populations ripple outward, altering herbivore numbers and ultimately vegetation patterns. In this framework, a single predation event is both insignificant and essential, one thread in a network too vast for any individual organism to perceive. The confrontation between a giant constrictor and a quill-armored rodent is therefore not an anomaly, but a brief intersection of survival strategies forged in isolation. No intent governs it, no malice or heroism. There is only the convergence of hunger, vulnerability, and opportunity in a forest whose cycles have repeated for millions of years, indifferent to which participant endures and which does not. The moment unfolds without announcement. The porcupine, having crossed a lattice of exposed roots, pauses at the edge of a shallow channel where floodwater laps against the last strip of solid ground. It lowers its head to drink, whiskers trembling as they touch the surface. Beneath that surface, less than a meter away, the anaconda has aligned its body along a submerged branch, every curve of muscle held in quiet suspension. The strike, when it comes, is not a dramatic eruption, but a precise displacement of water and mass. The snake's jaws close over the porcupine's shoulder and upper torso, teeth angle backward to anchor the grip as the coils surge forward in a single coordinated motion. Instinct drives the rodent's response. Quills flare outward, tail whipping, hind claws seeking purchase on mud that liquefies under combined weight. Several quills detach on contact, embedding in the snake's face and neck. But momentum has already carried the constrictor's body around its prey. One loop, then another, stacking layers of muscle that tighten incrementally with each exhalation forced from the porcupine's lungs. The surrounding water churns, releasing the smell of disturbed sediment and crushed vegetation. Night insects fall silent for a few seconds, then resume their metallic chorus, as if the disturbance were only another branch collapsing under the slow pressure of the flood. Constriction is a process measured in seconds for circulatory collapse, minutes for complete stillness. The The porcupine's movements weaken rapidly as blood flow falters, limbs stiffening not from suffocation, but from the brain's sudden deprivation of oxygenated supply. The anaconda adjusts its coils continuously, guided by tactile feedback that signals diminishing resistance. Quills continue to press into its scales, some penetrating the softer skin between plates. Yet the snake's physiology tolerates a degree of injury that would incapacitate a smaller predator. When motion ceases, the coils remain locked for several minutes longer, a safety margin shaped by natural selection to prevent premature release. Only then does the snake begin the slow task of repositioning the carcass for swallowing, seeking ahead to streamline the passage of quills along the digestive tract. This phase carries its own risk. Improperly aligned quills can puncture internal tissue. Field necropsies of large constrictors occasionally reveal such injuries, evidence that even successful hunts can impose delayed costs. Around them, the flooded forest resumes its indifferent rhythm. Frogs calling, leaves dripping, distant splashes of fish breaking the surface, while the snake's jaws work methodically, stretching ligaments that allow ingestion of prey wider than its own skull. Swallowing proceeds as a slow, mechanical progression rather than a single act. The anaconda advances its jaws in alternating motions, the left side gripping while the right releases and reaches forward, then reversing in a sequence that draws the prey inward millimeter by millimeter. Ligaments connecting the lower jaws flex without dislocating, an anatomical arrangement that permits extraordinary expansion while preserving structural control. The porcupine's quills, now flattened by moisture and pressure, lie angled backward, reducing resistance as the head disappears into the snake's mouth. Still, several catch against the edges of the jaw, forcing subtle adjustments. Tiny withdrawals followed by renewed effort to prevent them from splaying outward. Muscles along the throat contract in waves, guiding the mass deeper into the esophagus. During this phase, breathing becomes intermittent. The snake extends its glottis forward like a narrow tube to draw air while the mouth remains occupied, a specialized adaptation among snakes that consume large prey. The entire process can last more than an hour, energy expenditure rising as fatigue accumulates in muscles that have just completed a violent constriction. Once the prey is fully enclosed, the anaconda seeks deeper water, instinctively retreating to a place where buoyancy will support the added weight and reduce vulnerability. Digestion will transform porcupine's body into heat, growth, and reproductive potential over the coming weeks, acids dissolving bone, while specialized enzymes neutralize keratin structures that once served as defense. Embedded quills in the snake's skin may work loose gradually, or remain as minor irritants, a physical record of the encounter. For the surrounding ecosystem, the event redistributes nutrients rather than ending them. What was leaf matter becomes animal tissue, then returns to the environment through waste and eventual decay. Such transfers underpin the productivity of floodplain forests, where seasonal pulses of life depend on efficient recycling. By dawn, the surface of the channel shows no sign of struggle. Only a faint trail of disturbed sediment settles back into stillness, erasing evidence that two evolutionary paths briefly collided there. The forest does not commemorate the outcome. It absorbs it, as it has absorbed countless similar moments across uncounted generations. By first light, a pale mist gathers above the water, diffusing the sun into a muted glow that barely penetrates the canopy. The anaconda lies motionless in a shaded inlet, body distended by the outline of its meal, its metabolism shifting into a radically different state. Digestion in large constrictors is an intense physiological event. Heart rate accelerates, stomach acidity rises dramatically, and dormant digestive tissues expand to process the influx of protein and fat. Studies on captive boas and wild anacondas have recorded metabolic rates increasing several-fold after feeding, a temporary surge that generates internal heat even in cool water. During this period, mobility declines. The snake becomes vulnerable to disturbance, unable to flee quickly if threatened by larger predators or human presence. In the Amazon, adult anacondas have few natural enemies, yet jaguars and large caimans are capable of injuring or killing a sluggish individual. To mitigate this risk, the snake selects concealed resting sites, tangles of submerged roots, undercut banks, or dense floating vegetation, where camouflage and stillness offer protection. The porcupine's offensive quills, now embedded in the snake's skin and lining parts of the digestive tract, present an additional challenge. Most will pass through without consequence, but some may cause localized infection, a hidden cost paid long after the hunt concludes. The absence left by the porcupine is less visible but ecologically real. Arboreal porcupines are selective feeders, pruning branches and dispersing seeds through partially digested plant matter. Their browsing can influence which tree species dominate a patch of forest, subtly shaping canopy composition over time. Long-term studies of neotropical forests indicate that even small herbivores contribute to patterns of regeneration by favoring certain plants over others. The loss of a single individual does not alter the forest immediately, yet predation maintains a balance that prevents any one herbivore population from expanding unchecked. In this sense, the anaconda's meal becomes part of a regulatory system that stabilizes diversity across seasons. Scavengers receive little from such an event. Unlike a carcass left on land, the prey has been fully incorporated into the predator's body, so the nutrient transfer is delayed, returning to the ecosystem gradually through excretion and, eventually, decomposition when the snake itself dies. As days pass, the anaconda's body slowly returns to its pre-hunt dimensions, the visible swelling diminishing as tissues assimilate the nutrients. During digestion, the snake seldom feeds again. Its physiology prioritizes processing over further risk-taking. Movement resumes cautiously, guided by the same submerged pathways that structure its range, but with noticeable lethargy that can persist for weeks. If injuries from quills have penetrated deeply, healing will rely on a reptilian immune response that is effective yet gradual, influenced by temperature and overall condition. Field biologists occasionally document scars or embedded fragments in wild individuals, evidence of past encounters that did not end cleanly. Such marks do not carry memory in the human sense, but they reflect survival through imperfect victories. When the floodwaters eventually recede, the anaconda will follow the shrinking channels back toward permanent lagoons, its hunting patterns resetting to target more typical prey as terrestrial mammals return to established trails. In the canopy above the floodplain, other porcupines continue their nocturnal foraging, unaware of the event that removed one of their own. Reproductive cycles ensure continuity. Females give birth to a single well-developed offspring after a long gestation, investing heavily in each young rather than producing large litters. This strategy stabilizes populations in environments where food quality fluctuates and predation pressure is constant but diffuse. Over time, vacant feeding territories are reoccupied, browsing resumes, and the subtle pruning of leaves and bark continues to influence plant growth. Predators and prey thus remain locked in a dynamic equilibrium, each shaping the other's numbers without foresight or intention. The flooded forest, having absorbed the disturbance, transitions toward the next seasonal phase. Waters falling, sediments exposed, new growth emerging in the nutrient-rich mud. What occurred in darkness becomes part of an ongoing cycle, neither exceptional nor trivial within the scale of ecological time. In the flooded forests of the Amazon, survival is rarely a spectacle. It is a sequence of quiet transactions, conducted in darkness, concealed by water the color of tea and shadow. The anaconda's victory was not dominance, but continuation, a transfer of energy that will sustain a body built for patience in a world of seasonal uncertainty. The porcupine's loss was not tragedy in the human sense, but a fulfillment of a role written into the architecture of the ecosystem, where herbivores convert leaves into flesh and predators return that flesh to the wider cycle. No witness marks the boundary between success and failure here. The forest does not remember individuals. It remembers only patterns, flood and retreat, growth and decay, hunger answered and hunger deferred. Such encounters reveal a deeper constancy beneath the apparent violence. Every adaptation, whether coil or quill, is a negotiation with risk shaped over millions of years. Neither design is absolute. Each works until circumstance places it outside the conditions for which it evolved. When that happens, the outcome belongs not to strength or intent, but to alignment with the moment. In time, the snake will hunt again, the porcupine's kin will descend from the canopy, and the waters will rise once more to erase the boundaries between their worlds. What endures is not the struggle itself, but the balance it maintains, a system sustained by countless unseen exchanges, where life persists not through mercy or cruelty, but through the indifferent continuity of nature.